Good morning, students. Today's topic is electrophilic substitution reaction in phenol. Phenol. Phenol always offer electrophilic substitution reaction. And at first we know the group present on the ring is plus R group, and plus R group always offer the electrophilic to substitute at ortho and para position. We know that the lone pair present on the oxygen involved with the ring, and due to resonance the electron density form at this position and this position and this position. This position we know that it is known as ortho position, and it is a para position. It is also known as ortho position. This is meta position. Here it is also a meta position. So we know the resonating structure of phenol, in which we see that during the resonating structure the electron density appears at the position of ortho and para due to plus R effect of this OH group. So plus R group always substitute the electrophile at ortho or para position. If any electrophile means electron loving species, it always substitute. There is no addition reaction takes place. Always takes place substitution reaction. Here is the hydrogen. It removes hydrogen and get substituted. So in phenol always electrophilic substitution reaction takes place, and always the product will be ortho or para. So many electrophilic substitution reaction we will study in NCERT chapter. At first, the most common named reaction is Kolbe's reaction. Kolbe's reaction. The simple reaction, as we know, when phenol treated with sodium hydroxide and carbon dioxide in acidic medium, the formation of salicylic acid takes place. Acid. And also we know the epic name 2-hydroxy benzoic acid, or ortho-hydroxy, because this group is the main group, and with respect of this group this position is ortho. It is also known as ortho-hydroxy benzoic acid. What are the mechanisms involved in this reaction? Let us see. Mechanism. At first we see here oxygen attached with hydrogen, and it is more electronegative, so this bond shifted towards the oxygen, and OH ion from NaOH, because this reaction proceed in the basic medium. This OH ion takes these protons and it removes in the form of water. Now we have phenoxide ion. Phenoxide ion, and when this electron come towards, this goes from this position. Simultaneously, the carbon dioxide, which is acidic in nature, carbon or oxygen, this pi electron shifted towards this and carbon acquire positive charge. Here is the electron which goes at that position. Now we have double bond here, this bond as it is, and carbon, oxygen with negative charge. There is the double bond, and also one hydrogen present at this position. Further, when it goes from this position, it comes here and the removal of H plus takes place, and negative charge present on the oxygen gives to this hydrogen, and ring again gain their aromaticity by taking electron from the hydrogen. Next position, acidification takes place, H plus in H2O, or you can see that acidification takes place. Now oxygen takes this hydrogen and the formation of salicylic acid takes place. Once again, at first phenol, the electron shifted towards the oxygen and these protons taken by this OH ion and the removal of H2O takes place. Now we have phenoxide ion. Phenoxide ion undergoes to resonance. The pi electron when comes towards the ring, this pi electron comes to this position. Here is the electron dense position formed. Simultaneously, electrophile carbon dioxide take electron from here, means get substituted, and we have this structure. Here carbon with oxygen doubly bonded takes place, and here is one hydrogen open which lose their electron and remove from here, and negative charge or electron present on the oxygen take this protons. Now ring again get aromaticity by gaining electron from the hydrogen, and last stage, when this compound undergoes to acidification, formation of salicylic acid takes place. Salicylic acid or 2-hydroxybenzoic acid or ortho-hydroxybenzoic acid. In this case, this ortho-substituted compound will be more stable due to formation of hydrogen bond. Hydrogen bond, intramolecular hydrogen bond. We see here. Intramolecular hydrogen bond. Between this and this. Intramolecular hydrogen bond. Intramolecular hydrogen bond are those type of hydrogen bond which forms within a molecule. So ortho-substituted, this compound is more stable due to formation of intramolecular hydrogen bond. This is the first named reaction which is known as coal-base reaction. Next named reaction is Rimmel reaction. Rimmel reaction. It is also very important name reaction of phenol. Rimmel reaction, we simply write at first phenol when treated with sodium hydroxide plus chloroform. This is known as chloroform. And acidification done. So we have a compound which is known as salicylic. Salicylic and 2-hydroxy benzyl dehyde. Phenol when treated with sodium hydroxide and chloroform CHCl3 in presence of acidic last acidification done. So formation of salicylic formed. What are the mechanisms involved? Here is the electrophile at first generated chloroform in the basic medium. Chloroform at we write the structure of chloroform. Carbon attached with more electronegative chlorine atom, and this bond shifted towards, and OH quickly takes these protons and removal of H2O takes place. Now carbon here with electron density, and here is a good leaving group, chlorine also. It releases from here to form dichlorocarbene. Dichlorocarbene, we can see here it is also a sp2 hybridized we see here carbon 1, 2, 3, 4 valence electron of carbon and shared with two chlorine atom. In total 6 electrons are present at the carbon. So carbon is the electron deficient. So it is behave as a electrophile. So because it is a Lewis acid. At first, CHCl3 when treated with basic medium, carbon attached with 3 chlorine atom. Chlorine atom is more electronegative, so it pulled the electron towards itself, and carbon takes this electron, both the electron towards itself, and hydrogen taken by OH and released from here in the form of H2O. Now carbon acquired negative charge. Simultaneously chlorine, which is good leaving group, removed from here, and the formation of dichlorocarbene means electrophile generated. Now the reaction proceeded. Phenol basic medium OH from NaOH. This electron taken by oxygen and the protons taken by this OH ion and removal of H2O. Now the formation of phenoxide ion takes place. Phenoxide ion. Phenoxide ion get involved in resonance. This electron comes this position and this pi electron come this position. This is a phenoxide ion. This is a phenol. Now we have carbon double bond oxygen and the lone pair present, electron density at ortho position. This bond will be as it is. The electrophile, this electrophile take electrons from here and get substituted. Dichlorocarbon. Now we have one hydrogen is also here. This pi electron get towards its hydrogen, gives their electron and remove from here. And this protons take electron from here. Formation of CH, Cl2 and ring again get their aromaticity. Now 2 molecules of sodium hydroxide used. So if chlorine remove here because it is more electronegative, 2 OH ion get substituted at this place. 1 OH ion from here, 1 OH ion from here. Now we have 2 OH group attached with carbon. 2 OH group, if 2 OH group attached to carbon, this makes the compound unstable. So here is the removal of water molecules takes place. And the formation of carbon double bond at last, acidification done, and the formation of negative charge get this H plus from acid and the formation of salicylic dehyde. What are the mechanisms involved? At first, phenol in which oxygen attached with hydrogen. Oxygen first get the electron towards itself or pull the electron towards itself. H plus taken by OH ion and removed in the form of H2O. Now we have phenoxide ion and resonance start in phenoxide ion. Negative charge come towards the ring and the pi electron get at ortho position. Dichlorocarbon, which is a electrophile, quickly try to attach at this position because it is electron deficient and get electron from this position. This position is electron dense. When dichlorocarbon attach this position, hydrogen is present at this position, lose their electron, and carbon with 2 chlorine atom and negative charge appears, take these protons. Now CH attached with 2 chlorine atom, and chlorine is more electronegative, so it pulled electron towards itself. Simultaneously, pi electron shifted towards the oxygen and oxygen get negative charge. This compound, when treated with 2 molecules of sodium hydroxide, this 2 OH ion substituted T2 chlorine atom. Now the compound will be CH with 2 OH group. 2 OH group is attached with carbon, it makes the compound unstable, so there is a release of H2O takes place. Now we have a CHO group, and oxygen with negative charge takes, when acidification done, takes protons from acid and get converted into salicylic or 2-hydroxy benzaldehyde. It is a very important name reaction. When phenol treated with sodium hydroxide and CHCl3, which is known as chloroform, and second step acidification done, so formation of salicylic takes place. And this is the mechanism. Try to understand and learn. Now the third electrophilic substitution reaction is halogenation in phenol. When halogenation of phenol takes place in presence of carbon disulfide or CHCl3, which is known as chloroform, it is a non-polar solvent. Non-polar solvents, and their dipole moment is also very less. Then mono-substituted compound will be formed, orthobromophenol or para-bromophenol. Para-bromophenol, para or 4-bromophenol, and here is a orthobromophenol. So learn it properly कि when phenol treated with bromine in presence of organic solvents, means non-polar solvents, carbon disulfide or chloroform or any other non-polar solvents, then mono-substituted compound will be formed. And when phenol treated with bromine water, then tri-substituted phenol will be formed. Tri-substituted phenol, 2, 4, 6 tri-bromophenol. Because in presence of water there will be ionization of phenol get in a greater extent, so that substitution takes place all the position, ortho or para position available on, so that when bromination takes place in aqueous medium, tribromophenol will be formed. When bromination takes place in non-polar solvents or organic solvents, mono-substituted phenol will be formed. So it is very easy method For conversion, when phenol treated with orthobromophenol or parabromophenol, we will use organic solvent. When phenol converted to 2,4,6-tribromophenol, we use bromine water. In next class, we will see the mechanism of this reaction. That's enough for today.